Hello, modelling with parametric equations. This is a question you will find on the paper, not necessarily the parametric equation parts, but the modelling will turn up. A-level examiners want modelling questions on there where maths is used in a real life situation. So let's look at the one on this next page. And what you'll notice as we go through is it talks a lot about things that are linked with mechanics, you feel, but actually it is using your core math skills. So don't get put off because it seems to be talking about something that could be to do with mechanics when you need to sort of pick out and think about what skills have I learnt in my core or my pure maths that I can apply to this question. So a plane's position at time t seconds after takeoff can be modelled with the following parametric equations. So there's your clue. You're reading this question, you're thinking, right, this is actually a parametric equations question. If they didn't tell you that, you could grasp it possibly from here, though. If you look, it looks like you have 1, 2, 3, 4, 5 variables going on. And sometimes that you then think, oh, this is something I haven't seen or I haven't learned before. But what they're doing is they're going to help you through this. They're not going to just leave you there to work it out. Yes, this is something that you haven't had a whole exercise on, but I'm sure they're going to step us through it. So we know it's parametric equations, and we know we've got x equals v cos theta t and y equals v sine theta t. We then are told where v is the speed of the plane, theta is the angle of elevation, so that's shown on here, of its path, and x is the horizontal distance travelled, and y is the vertical distance travelled relative to a fixed origin. When the plane has travelled 600 metres vertically, it's climbed 120 metres. Find the angle of elevation theta. Now, it's asking you to find theta. Let's pick out some information here of what we've got. We've got that. I'm actually going to pick that out in pink. We've got this as well. The other piece of information is there and that there. So let's write this all out. So I haven't got it all up there at the top. So I've got x equals v cos theta t. I know that y equals v sine theta t. And it said when the train had travelled 600 metres that way, it's gone up 120 metres. Now, if I go back to the question, you might be thinking, well, I'm drawing my triangle, a bit of a wobbly triangle there. It does say, if we just read this question again, and notice I've spent a lot of time not doing maths, I'm trying to understand the question. And that's what you need to do. Spend your time reading it, understanding it. Don't start doing the maths because you're just going to waste time doing the wrong thing. A plane's position after takeoff can be modelled like this. When v is the speed of the plane, theta is the angle of elevation of its path. So if I think about it, the angle of elevation is theta, therefore this is my theta. Oh, and v would be, I can't quite perhaps draw that on, and this is my x is going in that direction, and this is my y. So actually I've now just worked out how to find theta, because I can just go that tan theta equals the opposite over the adjacent, and therefore if I do tan to the minus 1 of that, I would get the answer of 11.3 degrees to 1 dp. Make sure that your calculator is in degrees because that's what we'll be working for on this style of question. Right, just let me check I've got that all right. I've done it. Find the angle of elevation theta. I've done it. Yep, that's all good. Given the plane's speed is 50 metres per second, I've now been given a speed. Right, before I go any further, let me write that down. So I'm told that v equals 50 metres per second. Find the parametric equations for the plane's motion. Right, so I've got x equals v cos theta t. So that means x equals 50 cos 11.3, because I worked that out previously, t. I'm going to type that into my calculator and I get x equals 49.0 t, and there's my answer. And then here, when I'm doing y equals v sine theta t. So y equals 50 sine 11.3 t. And if I type that in my calculator, I end up with y equals 9.81. Oh, not quite right. Let me just, I didn't put a 1 there. 9.81 t. That's it. There's my parametric equation. So just let's think back. The beginning, it did look all a bit like this, and possibly a little bit scary. The examiner stepped you through it, and he or she, I shouldn't be sexist, he or she will do that. They're not going to leave you there floundering. So if it looks like something you've seen before, they will give you some helpful ways of moving towards getting an answer. If you think about it, other than the language, find the angle of elevation theta. You did that at GCSE. You didn't do the nasty words though. That's why it's now A-level, is that wordiness that's there. It's only words. So you've got to pick at understanding those words, but the angle of elevation, just stop to yourself and go, angle of elevation, what was that at GCSE? That's it. You can do it. It then tells you what the speed is, and actually part B is just substituting in numbers. And when you think of the maths involved, yes, it's substituting into a complex equation. But this is second year A-level exam paper maths we're doing here. So keep calm, just work your way through it. Now, part C. Find the vertical height of the plane after 10 seconds. Vertical height of the plane. Well, that would be wanting to know what y is. And we want to know y when after 10 seconds, so when t equals 10. So C, I'm going to say y equals 9.81t, because remember that's what we can use now. We don't have to go back and use that more complicated equations we've used before. So when t equals 10, y would equal 98.1 metres. That's it. Part C done. Nothing more. So that was substitution. Let's keep going. We're doing well now. Shown the plane's motion is in a straight line. So how am I going to do that? How am I going to show something's in a straight line? So immediately I'm thinking, right, straight lines, GCSE, all straight lines. They were like y equals x, or 3y equals 4x plus 7, or 10y equals 5x minus 12. So really, is that not asking me to find the Cartesian equation? Because all the equations I know were straight lines. They were that y equals mx plus c thing. There was no t in there. But again, they haven't said find the Cartesian equation. They've said explain it's a straight line. But the best way to do that is having a Cartesian equation. So let's do that. So D. Well, I know that x equals 49.0t. So therefore t equals x over 49. So if t equals x over 49, and I know that y equals 9.81t, then y is equal to 9.81 multiplied by x over 49. And if I put that all together, my answer would be y equals 0.2x. That's my Cartesian equation. And this is a linear equation. Linear meaning it's a straight line. Remember, quadratic would have an x squared in. So this is a linear equation. So let's go back to get the correct language from the question. It says show the plane's motion is a straight line, which shows the plane's motion is in a straight line. Now notice there, I'm going to say it again. The actual question didn't say find the Cartesian equation. It said show that it moves in a straight line. That's where they're expecting you to be an A-level student again. It's talking about being a straight line. What do you know about straight lines? They're y equals mx plus c. It's a Cartesian equation. I need to find the Cartesian equation. That's the thinking process you need to go through. And that's quite challenging, but it only comes with practice. And yes, you may not at the moment be at the point of doing exam papers, but that's why you do lots of exam papers, and you must keep doing exam papers. So, last part, let's have a look. Explain why the domain of t is greater than naught is not realistic. Right, I'm going to go back and look at what this question's about because I'm starting to forget. Because sometimes it's in here. A plane's position at time t seconds after takeoff can be modelled with the following parametric equation. Right, which we also know are a straight line. A straight line of the form y equals 0.2x, which is right down here. So this means that for t, it's moving in a straight line with an increasing gradient. Well, if that continues for t is greater than 0, it just means it's going to continuously just go upwards and upwards and upwards and upwards. Now, I'm not a great traveller on planes, I'm going to be honest. I have been on quite a few in my life, but I don't go on one every year. That's my bit for the environment. But if I go up and up and up and up and up, I'm never landing. And I'm not doing the rocket thing here. So this model is actually falling apart. It can only be for part of this plane's journey that it just can keep going up and up. Because remember, if you think about that as a graph, it's not going to be a very steep gradient. It's going to be like that. But a plane doesn't just keep going up. It goes up, it goes along, it comes down. It might go up and down in between as it changes, but generally, basic thing, up, along, down. That's planes. So, E, if we remember what the question is explain why the domain of t is greater than 0 is not realistic. It's because planes actually I should put the plane would be continuously climbing. Therefore, t is greater than naught is not realistic. And that's that question done. I think it's good to look at a second one. Here we go. So again, modelling question. What are we modelling this time? A figure skater. So next time you see dancing on ice, you can write a parametric equation for it. So the motion of a figure skater relative to a fixed origin O at time t minutes is modelled using a parametric equations. Lucky figure skater. I bet that figure skater, he or she is brilliant at maths, where x and y are measured in metres. Find the coordinates of the figure skater at the beginning of this motion. So at the beginning means when t equals 0. So let's go with that to start with. So A. I'm looking at the beginning, so at the beginning t equals 0. So x equals 8 cos of 20 times 0. Well, the cos of 0, because 20 times 0 is 0, we know that comes out to be 1. So the answer for this is 8. And then looking for y equals 12 sine of 10 times 0, subtract pi over 3. And if you type that all into your calculator, minus 6 root 3. So it's asked for the coordinates. There we go. Done. Fantastic. You know where that figure skater is going to be at the beginning. And it then says find the coordinates, the point where the figure skater intersects his own path. Oh, it is a he. That's lucky we found out. So it's saying where intersects his own path. Well, that's here. Okay. Now, because it's not particularly clear here, if I'm honest, this is where along it also crosses the x-axis. So I know that it's where y equals 0. So y equals 0 is what we're looking for here. And if I put that into my equation for y, which is up there, I get 12 sine of 10t minus pi over 3 equals 0. And therefore I get 12. I'm going to divide by 12, and I'm going to write sine of 10t minus pi over 3 equals 0. So if you think about it, I need to write down all the places where sine to the minus 1 of 0. So that would be, let's just get rid of that there. We'll put the 3 back in. So that would be 0. It would be pi, 2 pi, and so on. You're then going to add on, remember, pi over 3 to each of those. So that would be 4 pi over 3. That would be 7 pi over 3, ... and then you're going to get that t would equal, because you're dividing by 10, pi over 30, 4 pi over 30, 7 pi over 30, and so on. Yep. Now, if we remember, and we just go back up, because we might have got a bit lost in the question now, that what we're actually getting at here is we're trying to find this point, and we're assuming that the skater is doing something like this all the time. So, yes, this does happen at, I think it was pi over 30. So if we start like this and we go off and we say, right, pi over 30. Oh, here we go. This will be 4 pi over 30. And again, 7 pi over 30. But the actual value for x, because remember, x is going to be the same value each time. What is actually changing is the value of t. So if we just choose any one of these and put it back into x, just get my x equation, because my x equation is 8 cos 20t, 8 cos 20t, so that would be 8 cos of 20 times pi over 30. And if you go about typing that in your calculator, you'll get it's equal to -4. So we want to find the coordinate at the point where the figure skater intersects his own path. It would be -4, 0. Because that's my x value is -4 and the 0 because it happens on the x-axis, so y is 0. Right, moving back up, let's find C. Oh dear. For C, we want to find the coordinates of the points where the path of the figure skater crossed the y-axis. So let's look at the graph. Wow, she cuts the y. Oh, he cuts the y-axis 4 times. That's quite a lot. So I'm just wondering how they managed to get the x and the y-axis. You know, did they draw it accurately on the ice, or maybe they didn't bother. But anyway, find the coordinates of the point where it cuts the y-axis. What does this actually mean? Well, what it's getting at is if it's cutting the y-axis, x equals 0. So if x equals 0, then 8 cos 20t equals 0. Because x equals 8 cos 20t. So 0 equals 8 cos 20t, and 0 equals cos 20t. And if we then solve for that using our calculator, we'll know that cos is 0 at pi over 2, and then again at 3 pi over 2, and at 5 pi over 2. And I actually want 4 solutions, so I'm going to keep going. 7 pi over 2. So notice me looking at, if I hadn't looked up at that graph and realised that there were 4 places and done that before I started the question, I may not get the right answer. And students often go for getting on with the maths and not doing that pause to think first. And if you can just slow down and pause, easily said in an exam, that's where you get your marks. So just do look at the graph. They haven't put it on there because, you know, they thought it'd be nice for you to see what it'd look like. It's got value. They're trying. It's usually got clues on how to answer that question. Right, so that's 20t. So we now can work out what t is. And it's going to be pi over 40. It's going to be 3 pi over 40. It's going to be 5 pi over 40, and it's going to be 7 pi over 40. And then from here, so we now need to find our y value. So I need to write the y graph down. So y equals 12 sine y equals 12 sine of open bracket 10t minus pi over 3. So you would then substitute in to this each time one of the values. So you're going to have t equals, for some reason it's not writing all of a sudden, t equals pi over 40, y equals 12 sine of 10 times pi over 40 minus pi over 3. Put that in. It's your calculator, negative 3.11. So that's the first one. And you just keep going for each value. So I'm just going to then say, right, the next one is t equals 3 pi over 40. So you'd get y equals, so it's just substitution, which I'm sure you're brilliant at, just putting the numbers into the equation. Then t equals 5 pi over 40. And that one will give you y equals negative, is it negative? No, 3.11. And then you've got t equals 7 pi over 40, which gives you y equals 11.59. So they're your answers for where it crosses, and then you're just writing those as coordinates. So you could then go, right, that's 0, negative 3.11, 0, 11.59, 0, 3.11, and 0, 11.59. Just looking back over those values, that last one should be negative there. I'm going to put it in pink so you can see that should be a negative. So that there should be a negative, because otherwise it didn't make any sense. That's why I just scrolled up and scrolled back down, because the values, when you look at the graph, look, I went, oh, hang on a moment, I seem to have got the same one out. So you'll see there's 2 negative and 2 positive. Right, so that's that done. And we're left now to do D. Determine how long it takes a figure skater to complete one complete figure of 8 motion. So here we're looking, when you're saying how long it takes a figure skater to complete one complete figure of 8, we're looking at how often it repeats. So if I go over here, and I've got, this is part D, and I've got x equals 8 cos 20t. Now, if you think about the graph, cos 20t, that repeats every 2, not actually, cos of, if I had the graph cos t, that repeats every 2 pi, if you think of a graph, a cos graph. But I've got 20t. So here, the period for that one would be 2 pi. But here I've got cos of 20t. So that means that it's going to repeat quicker than that. And from that, I can actually say my period would be 2 pi over 20. So it would actually repeat, or which is the same as pi over 10. And then the next time that would happen would be pi over 10 later, which would be 2 pi over 10, and then it would be another pi over 10 after that, so it'd be 3 pi over 10. So that's how often it would repeat. Now let's look at y, because y we have that y, going back to my equation over here, is 12 sine of 10t subtract pi over 3. Now, the subtracting, if you remember, just shifts your graph left or right. It doesn't alter how often it's going to repeat, how quickly it repeats. That's affected by the 10. So if we know that sine t has a period of 2 pi, then the key bit here on how quickly it repeats is that part, because as I'm going to say again, adding or subtracting in the bracket just shifts the graph. It would still repeat the same amount of time, because if you draw a graph from a point, it would still be 2 pi. If you move that point, it's still 2 pi. However, multiplying it by 10, that does affect the graph. Remember, it stretches the graph, and it can be obviously a stretch, which is actually more of a squish. And so here, the period would be 2 pi over 10, which would then be 4 pi over 10, or you could cancel that down. But the reason I haven't, you'll see in a moment, which was rather lucky, is that if you look at that 2 pi over 10, that repeat is the same as that there. So that figures in the x and the y. So once it's happening in both, we then can therefore say, to answer my question, determine how long it would be t equals 2 pi over 10. And you would want to put that into your calculator. It would be 0.628 minutes, and you can work that out as 38 seconds. Oh, that does look like an S. So that last part I think is a bit of a challenging thought, and it actually brings in a bit of graph transformation knowledge. Do you really understand what's going on? Not going to be big marks, please be assured, but it's not hard, but it's big thinking, and that's what the A-level does like to test. Okay, think you now need to do some practice.